No, straight on.
Hello everyone. Sorry that it took longer than usual. So welcome back everyone. This is machine design course MECH 364. So today we are gonna go through the syllabus and have a quick review on the first chapter. I already posted the files for the chapter 1 that you can study at home. And tomorrow we are going to start our first lecture, which is going to be stress analysis. For about 3 to 4 weeks, we are going to have review on the materials that you have covered in strength of materials course, and then we go through the chapters that we are supposed to cover in this course. All right. The TA for this course is Ramin, so this is his email address and phone number. I have open door policy. You can stop by my office at any time that you can find me in my office. But the official time would be Monday, Wednesday, and Thursday, 10 to 12. Or you can shoot me email and set an appointment. The textbook that we are using is the Mechanical Engineering Design by Shigley. So it's a 9th edition. So you might have difficulty to find the new edition, but you can find the used version of this book online, or electronic version also is acceptable if you want. But the homework and the material would be based on the 9th edition. So the course has an active Canvas, and to organize the file, I'm using the modules. So you don't need to go to the file section and the Canvas. When you go to the page of this course, you can log into the modules. I organize the file based on the weekly material that we cover in this class. So homeworks, materials, they have been there and you can find them. What we are gonna learn in this course? Suppose this course is about mechanical components. There are different types of the mechanical components like beams, columns, springs, shafts, buildings. So we want to design, we want to learn how to do analysis and design of mechanical consider this cantilever beam with the length of 25 inch and the square cross section. And one force applied at the end with the magnitude of 500 pounds. So if you are given with something like this, you are given with the dimension of the component and the cross sections size also is given. So you are supposed to find the stress applied to this cantilever beam, and you want to answer this question if this cantilever beam can support this load or not. If you are doing something like that, you are doing the analysis. So you are the mechanical components dimensions are given, the loads are given, and you are answering this question if this mechanical component can support this load or not. So this is one thing that we are going to do in this course. If I provide the same things except we don't know about the cross sections dimension. We know that it's a square, but we don't know about the dimension or the thickness of the cross section. And this force is applied there, and you want to design the cross section such that it can support this 500-pound force. So now you are doing the design, and you are gonna find the thickness for this cross section. So this is the two aspects of things that we are covering in this course. We are doing these things for different mechanical components like columns, power screws, shafts, and those stuff things. And at the end of semester, you are supposed to be proficient in stress analysis of mechanical components, like I said here. You are supposed to be able to do the analysis, and also you are supposed to design a mechanical component to meet the design and specification. So these are the things that we are covering in this course. And the topics that we go over this course, as I said, we go through the basic concept in design. Today I have a quick review on that, but I leave the slide for you to study that. Then we go through the fundamental of stress. As I said, these are materials that you have learned in the strength of material course. Then the first component that we go through, that is the beams, force analysis, stress and strain for the beams. It's going to be covered. And cylinders, next component, columns. By end of some semesters, by end of columns, we have the first midterm. Sometimes I stop here and I'm going to have the first exam before we go through the columns. Yes. And then after the midterm, we are going to go through the solid materials chapter 2. And we are going to talk about failure theories when the load is constant or static loading. This 500 pound is not changing. It's the constant loads. What would be the failure theories that we can use? And then we go through the very important topic, which is variable loading. If this 500 pounds is changing, suppose it's varying between 0 and 500 pounds, then we are going to have another problem here, which we call fatigue analysis. We go through that concept, which is new for you. And then after we cover the fatigue, we can talk about the shaft, because shafts would be the components which they are under variable loading. The loads on the shafts, it's changing, so we need to cover the fatigue before we go to the shaft analysis. So if we have time, we go through the fasteners, welding, this course usually is offered in two different sequences, machine design 1 and machine design 2. So these components that you can see here should be offered in machine design 2, but I have it there. If we have time, we go through them. But the last 5 years, I couldn't cover them. So I guess it's going to be the same for this semester. So for the grading, we have 2 midterms. Each 20%, final exam 30%, and the homework has 25%, and class activity has 5%. We don't have any project for this course. And for the grading, 85% and above is getting A, and 50% and below is getting F, and I distribute the grades between 50 and 85. So, we have about 11 homeworks, 11 to 12 homeworks. It's a weekly homework. I will assign the homework every Thursday, and I will collect week after that in the class on Thursday. Some homework needs to be done by MATLAB, like the machine candy class. Some of the homework needs to be done by MATLAB, but it's not as heavy as K&D course for the MATLAB part. And there is a toolbox in MATLAB I already posted in Canvas. Some homework needs to be done by using this toolbox, Mechanical Design Toolbox, MDT. For the first homework, you don't need that. Or maybe for the first homework. Second homework has, I think one problem needs to be done by MDT. When we go there, I will talk about this toolbox, but if you like, you can download that toolbox now and save it on the desktop or on your laptop. And it has different toolbox. One is for the Moore circle, one is for beam analysis, one for fatigue analysis. Depending on the homework that we are working on, that we are using that specified or corresponding toolbox. So if you have, I will go through the toolbox when it's needed, but you can ask me after the classes, so we can figure out how it works. We have 2 in-class exams, and I will let you know at least 1 week before the exam date. Usually the exam would be closed book, but sometimes depending on the exam, I'll change it to the open book exam. So this is just for record, but I may change it for exam 1 and 2. The final exam has been scheduled for the weekend. It's the first time that I have the exam for the weekend. I don't know why, but it's Saturday, May 11, 1:15 to 3:15. And for the exam, it's a comprehensive exam. So, and for the exam that we have, please bring the drafting instrument. We need it for Moore circle. Basically, if I ask you about that. Any question about the syllabus? Again, for the Canvas, you better use the modules. I post the files. I organize the files in the modules, so look at them through the modules on the Canvas. Alright, let me have a quick, I posted these slides, this file on Canvas. I would like to go through some page of these files. So, but you can read it by yourself. So, mechanical design has involves the different aspects of or different disciplines of mechanical engineering. Not just only 1 or 2 disciplines. For example, if you want to design a journal bearing for the shaft, you need to bearing. If you need to, when the shaft is rotating, the bearing allows the shaft is rotating freely through the bearing. So when you want to design the journal bearing, you need to know the flow. you consider the flow for the lubrication of this bearing. You need to know about the heat transfer because you don't want to get excess heat here. You need to know about the friction, energy transport, and some other discipline should be considered on your design. So it's not just only one discipline should be considered. So design has 6 phases. So as you see, this is the 6 phases for design. It's starting with identification of need. Suppose you need to design a jacket stand. This is this is a recognition of need. You know that you need to design a jacket stand. And then after that you go to the definition of the problem. How much weight should be supported by this jacket stand? So you just define the problem after you recognize suppose you figure out that you want to design a jacket stand such that it supports 7,500 pound weights on that. Then on phase 3 synthesis, you do the brainstorming. So you come out with some idea to figure out what should be the design for this jacket stand. It can be there is no true or false design. You just do the whatever you think can be a good candidate. After you do that, you just evaluate the candidates and come out with the best candidates and your start analysis and optimization. Suppose you come out with number 3 as a best candidate and then you do the analysis and optimization. Basically you are sizing the components of this jacket stand. And then you evaluate your design after you are done this, and then you present your design. And as you see, this is iterative process. So a full example of jacket stand has been posted in Canvas. It's a 7-8 page handout. You can look at that through all 6 steps for this example. It's going to be more clear if you go through that. So these are the steps for the design. As I said, you need to consider the different aspects depending on the application of your components. These are some characterization that you need to consider for the design. You have heard about the standard and code. What is the standard and code? A standard is a set of specification for components or parts, material or process. So a set of specification. What would be the application of code? It's going to help you to have a uniformity and a specified quality. So if you have a standard, for example, for this is a pipe. If we have a standard for the pipe, if I say I would like to have a pipe with the nominal size of 1 inch, everybody will know that by looking at this table, everybody will know that the outer diameter of a 1 inch pipe is 1.315 inch. So you can have a specified quality if you define a standard for the parts or process. What would be the code? Code is a specification of a set of specification for the analysis and design methods. And what we will get by using the code, we can achieve the specified degree of safety. So if you use the code, we can get the specified level of safety if everybody use the same code. And who is gonna publish the code and the standard? There are different or various organizations. They publish the standard and the codes for the common industry or critical industry. These are some examples for the organization working on or publishing the codes and the standards. For example, these are the names that you will hear many times in this course. AISI, American Iron and Steel Institute, or ANSI, American National Standard Institute, or ASME, American Society of Mechanical Engineering. These are some organizations, they publish different standards and the codes, standards dealing with the parts, material, or process, codes dealing with method and design process. One thing which is important in design is the cost. You want to consider the cost as a, if I don't say most important factor, it's at least one of the important factors in engineering design. So using the standard size is going to help us to save or reduce the cost. So a standard size. Suppose you design a pipe, and you figure out that the diameter for the pipe should be 1.2 inch. You can order a vendor to build this pipe for you with 1.2 inch, or it's going to be less expensive if you go through the standard size. These are the standard size that you can find in the market. As you see, the size that you are looking for is 1.2 inch. But the standard size that we have in the market is 1 inch, and the next one is 1.25. So it's less expensive, much less expensive that you go with a pipe with diameter of 1.25 inch rather than ordering this size for the pipe. So by using the standard size, we can reduce the cost. So on your design, if you come out with a dimension or the size that you couldn't find the exact number in the table, you round it to the closest standard size. So 1.2 inch, I round it to 1.25, which is one of the value that I can find in the table. So why do we do that? Because we want to reduce the cost in our design. Another thing that we need to know before we start the analysis is strain and stress. Strain is the inherent property of the material or mechanical component. So it depends on the process, the treatment and the processing of the material, how it can be how it was the treatment and how it was the processing of that material, if it's hot rolled or cold drawn. We will go over the hot rolled and or cold drawn on chapter 2 briefly. And the examples for the strength, if you remember, it was ultimate strength and the yield strength. These are the things that we have to represent the strength of the material. Table 820 to 827, it's going to show us the different strength of the different materials. You remember I told you on the standard part, one of the organizations that you will see is AISI, American Iron. This is the standard for the steel. AISI number 1006. If the processing is the hot roll, the tensile stress is 300 megapascal, and the yield strength for this material is 170. This is table 820. From 820 to 827, you can find the strength of different materials. And the material, they have been labeled by the different standard. One of them is AISI, the other one is SAE, or the other one is UNS. Depending on which standard you are using, they have a different name. So if you are given, for example, with the material made of AISI 1015, cold drawn, you can look at this table, find 1015, cold drawn, you can get this information. 390 megapascal for tensile strength, and the yield strength is 320. If you are looking for PSI unit, you can look at these numbers: 32 kpsi, kilo pound per square inch, and 50 and 27.5. That was the strength. Stress is the state property at a specified point of a body. So we define the stress for a point on a body, and it depends on the geometry of the body and the load. The magnitude of the load and the geometry of the body. Alright, suppose the material that I have for this cantilever beam is 1015 cold drawn. I come here and look at 1015 cold drawn, 390 megapascal is S ultimate, or ultimate strength. But we are not living in the perfect world, so we might have some uncertainty in the nature. So how do you know that the ultimate strength of this material is exactly 390? It might be 380, it might be 402 megapascal. So, and there are different reasons that we might have this uncertainty in our design problems. So how can we consider this in our design? We are using the safety factor. Let's see what's the safety factor or design factor. Suppose this beam is made of AISI 1015 cold draw. We know that the S ultimate of this is 390 megapascal. It's under axial tensile load. Tensile load means we have tension in the component. Compressive load means if we have compression in the component. Here we have tensile load. If I ask you what would be the stress applied to this bar, we can say the stress is force dividing by the area, which is the cross section. Suppose it's 1 inch by 1 inch, so P dividing by A, which is 1 times 1. Now, if we are living in the perfect world, what would be the maximum stress that this component can support? It's going to be ultimate strength. The strength of the material, the maximum allowable is going to be 390 megapascal. So you can increase the load such that the maximum stress or the stress is less than 390 megapascal. But since we have some uncertainty in the problem, you cannot say that the maximum allowable stress is 390 megapascal. So you define a safety factor. You say due to the uncertainty, the maximum allowable stress is going to be S ultimate dividing by factor of safety or design factor, which is greater than 1. Suppose you consider ND equals to 2. So the allowable stress is going to be 390 dividing by 2, 195 megapascal. So you can increase the load such that the stress applied to this doesn't exceed 195 megapascal. So this is the definition of factor of safety or design factor. Why do we need design factor? Because we have uncertainty in the nature of the design. So S is the strength. How can I find ND? This is another form of this equation. Any question on this? These are just some quick reviews on the terms that you may see in this course, but we will go in details when we start our first lecture by tomorrow. All right, I'll see you.